Hello mga kasugilanan. Have a nice day. And we are now in our week number 2 for our intended for our STEM students and other courses or strand who really need this kind of topic. Well, shout out to our STEM students, especially in the Kaga National High School. Well, this is me again. I am your teacher in chemistry. I am Rafael P. Inson. This second week, in which is in part of our curriculum, or week number 2, it's all about measurement. Well, we will be dealing with numbers, how to use numbers. And of course, to begin with our topic for today, let's begin with our topic contents. Especially first is accuracy and precision. So we'll be talking about the accuracy and precision, and of course, the significant figures in calculation. I know that you have been encounter and what do you call this one experience about how to deal with significant figures in your junior high school, and today it's a matter of recap and of course in the level of mastery. And third is rounding off numbers, and we have to master how to round off numbers and exponential or scientific notation, and lastly dimensional analysis or factor label method. So this is our topic content in this video. Let's start. What happened to the measurements? Measurements. So in the first place, what have you understand about the meaning of measurement? Well, we have a different meaning of measurement, but in the context of science, measurement is a quantity that has both a number and of course a unit. So you will be dealing with numbers with their corresponding unit. And of course, when you say measurement, it is a fundamental to experimental science. So must be able to take and evaluate them. So meaning to say, in every part of the experiment, you have to deal with numbers. You have to deal with measuring technique in the whether in the form of liquid, solid, and of course, etc. Depending on its nature, we have to use also with their corresponding apparatuses, no, for liquid, for solid, and of course for gas. And to begin with our topic content, let us differentiate and define the difference between accuracy and precision. Well, accuracy is a measure of how close a measurement comes to an actual or true value of whatever is being measured. So, meaning to say, you have your standard value that you are trying to achieve, no, upon how you measure a certain substance that is being required in your experimentation. And of course, precision is a measure of how close a series of measurements are to one another. So, meaning to say, it would involve a lot of trial because when you say closeness, you have to consider and refer your first reading to the second reading and to the third reading or trial 1, 2, 3, and etc. Well, have you imagined playing in a dart when our measured value, standard value is the bull's eye, which is 100 points. And in your first trial, you push a dart, or you use a play of a game of dart, and then all of your trials is really hitting to the bull's eye. All of the, say, for example, 5 trials. So, meaning to say, since you are getting or achieving the accepted value, the closeness of your target, which is 100, and you also got a 100 score, meaning to say you are very accurate. Meaning to say, among the 5 trials, first attempt, second trial, third trial, fourth trial, and with that, the same way of getting the 100 points or both eyes is what we call accuracy. So you are very near to the accepted value or the true value, no matter how many you've tried, no, you've tried or how many trials you have done. And of course, the precision, of course, is the closeness of the first trial, second trial, and third trial. So if the first trial is 100, second trial is 100. So when we see precision, there is a series of tests, series of trials that you have been done. So meaning to say, the same lang gihapon ang imong score, and you are very precise. So in this first letter A, you are a very accurate because you hit the target or the accepted value, the true value, and of course you are very precise, which it's because you got the same remarks, which is the same with the first until five trials. And of course, when I say for the letter B, an illustration of that is it's a poor accuracy. Why? Maybe you got only 50 points out of 100, so it's very far away from the true or accepted value. But you are good precision because no matter how five trials that you have been made, and you got the same points, which is 50 in the first trial, second trial 50, third trial 50, six trials, whatever trials you have been done, it's very close to each other. You know how many series of trials, closeness of each trials, that is what we call precision or very precise. But as I said, if it is very far from the true value, you are not an accurate. Okay. And for example, the letter C demonstrated very far away from the accepted value and very far from away from each other, how no matter how trials that you have been made. So you are not accurate and you are not precise as well. Okay? So because your trial is very big difference from the second trial, third trial, and so on, you are not really consistent. So you are not precise as well as you are not accurate because your your series of attempt is far away from the true or accepted value. Okay, I hope that you understand what is precision and accuracy. So the precision is reproducibility, check repeating measurements. Poor precision results from poor technique. So meaning to say, there's something how you handle your way of reading. You are not really skillful upon reading because you are very poor in precision. Your first trial is very different from the second trials. You are not really precise. And for the accuracy, the correctness, no, check by using different method. Poor accuracy results from procedural or equipment flaws. So meaning to say, if you are not really accurate in your experiment because you are very far away from the accepted value, there's something wrong with your procedure, the way how, or method, the way how you handle your experiment, the way how you manipulate, or not really manipulate, the way how you operate your experiments, because you did not get what's the best results, and it's very far away from the true and accepted value. Or you're not if it is not in the method, or if it is not in the procedure, maybe and there's something wrong with the equipment. You try to check that one. You try to check your skills, your experiment, your method, the procedure, or the experiments, or the apparatuses as well. No, you have to double check those methods so that you will get a very accurate results. What I'm trying to say, if your result is very away from the accuracy or the accepted value, there's something wrong with the procedure or your apparatus or instrument. Okay, that's the source of error. Well, in evaluating measurements, it's often we are experimentally determining the value in the lab that is already known. And when we do this, we must calculate error in order to see how accurate and how precise results are. Okay? So that's it. And in the lab reports, you will be required to determine your error and percentage error. That is really an SOP, the standard. So in dealing with the reports, experiment, of course, your weapon there is you have your laboratory notebook, laboratory reports. This is the way how you present your experiment, or yes, in the form of laboratory reports. You must have a very good results because you're very skillful, and of course the way how you read that one, and in everything that you have done in the experiment, it's not really perfect. So there's something, an error, a source of error, human error, apparatus error, method error, and etc. And you have to calculate your error. So meaning to say, in a way of calculating your error, There's a formula of calculating your error. So but the method that you're trying to consider there in the error is the accepted value, which is the correct value based on reliable experiments, and of course the experimental value, and that value is measured in the lab. So meaning to say, experiment itself, your actual results accepted value is a constant, maybe it's a standard value. And in getting the error, you just try to make a difference between the experimental value and an accepted value. And having that formula, yes, that's an error. Experimental value and accepted value is you, so that you will know how much of your error. And when it comes to percentage error, it's just simply percentage error is an absolute value of an error divided by an accepted value multiplied by 100%. Take note that percentage error, which is equal to error over accepted value, and your error is an absolute value. The two bars there in the numerator signify that your error is an absolute value, meaning to say it does not matter how what is the sign, if it is either negative or positive. No, do not consider the sign, times multiplied by 100%, and that is how you calculate your percentage error. Of course, question number one, the accepted value for the boiling point of water is 100 degrees Celsius. In the lab, you experimentally determined to be 98.7 degrees Celsius. What is the error and the percentage error? Try to think with that one. Compute using your ballpen, paper, and of course, with the help of calculator. Again, how to compute the error? Using that formula, and of course, the percentage error using in the previous slide. What is that? To check. Experimental value minus accepted value for the error, and the percentage error is the error or over accepted value times 100%. And that is your answer. You have to practice that one. And error and percentage error, yes, I should not have to present the answer, but of course, for the benefits of those persons who are not, who are really confused, well, this is the answer. Accepted value or the true value is 100%, and your experimental value stated in the problem is 98.7%. And for your working equation, yes, error experimental value minus accepted value, which your experimental value is 98.7% minus 100, which is accepted value, which should be negative 1.3 degrees Celsius. Do not forget with that one. But since to get the percentage error, it's an absolute value. So that's why, yes, just put 1.3 over accepted value, which is 100 times 100. And that is your percentage error. Well, that's it. How to compute your error and percentage value. And the second topic we have is the significant figure in calculation. What is significant figures? Measuring device determines the number of significant figures as a measurement has. Significant figures reflect accuracy of a result of or a measurement. And in knowing the significant figures, we need to determine the correct number of significant figures to record in a measurement, okay? And to count the number of significant figures recorded in or in a recorded value, and of course to determine the number of significant figures that should be retained in accuracy. That's what we really need. I'm very excited. So upon measurement, you have to measure using the value, and of course with their corresponding unit. Please include the unit. Yes, in the illustration, the measured value is 5.4 and the unit is a centimeter using the roller. And the second letter B is 5.36 centimeter. Take note that always the numbers always accompanied with the unit, because there are a lot of numbers in the world and we have a specific unit, because if you don't indicate the unit in terms of centimeter, maybe some other would label it as a kilometer or whatever, gram, etc. So that's it's very necessary and important to indicate the unit. The significant figures, all digits in a number representing data or results that are known with certainly plus one certain digit. So there are rules in determining the significant figures. Well, rule number one, or the first rule, any digit that is not zero is significant. Take note that from 1, 2, 3, 4, 5, 6, 7, 8, 9, all those numbers are significant except the zero. That is rule number one. And 1.2345 kilo, 1.234 kilogram has four significant figures. And of course, when it comes to zero, the zero are sometimes called a sandwich zero, trailing zeros, leading zeros, etc. When zeros between non-zero digits are significant, as some other rule in name this as a sandwich zero. Sandwich zero as those zeros that in the middle or in between the non-zero digits. In times like that, that zero is considered to be significant. Okay, take a look for example, 606. So zeros is a sandwich, meaning to say it's between non-zero digits, which is 6 and 6. So therefore, there are six significant figures. And of course, zeros to the left of the first non-zero digits are not significant. So meaning to say, if the number is less than 1, of course, if the number is started into is considered to be as less than 1, you have to start in 0.0 0 point something 0. So if the number is less than 1, say for example 0 point something 0, then those zeros are not significant. Zeros after to the right of the decimal point is not significant. So for example, di ba 0.08 is less than 1. So ang 0 is not significant, and after sa decimal point ng 0 and then 8, the 0 to the right of the non-zero digit is not significant. So meaning to say, sa Bisaya pa, ang kanang mga zero after sa decimal, if the number is less than 1, are not significant. So meaning to say, 8 is only one significant. In 0.08, liter 1, only one is significant, which is 8. And of course, if the number is greater than 1, then all zeros to the right of the decimal points are significant. Say, for example, if the number is 1 or greater than 1, all zeros after the decimal points are all significant. Okay? 2.0. So there are two significant because 2 is greater than 1, and after the decimal point, 0 is considered to be a significant. And of course, if whole numbers have zeros to the right with no decimal, then all zeros to the right are not significant. Sa man mga trailing zeros. For example, if the numbers is very large, you don't have any decimal point, kanang mga zeros, especially if dili decimal after sa mga non-zero digits are not significant, no? If comma lang siya. So take note, 560. So there are two significant kay wala man siya decimal places, or kanang zero dra is what we call the trailing zero, two significant figures. And of course, if the number is less than 1, then only zeros that are at the end and in the middle of the number are significant. So meaning to say, if less than 1, all zeros after sa mga dili non-zero digits, mga significant na siya. First, say for example, ang 0.00 not significant, 420, kanang 0 to the last are significant. That's according to the last rule. So that's why we have three significant figures. That's it. That's how we are trying to deal with the significant figures and try to practice that one, because maybe in the next day and the next day around, I will give you a long quiz. Some of it will be taken from this slide or PowerPoint presentation. So example of significant figures. How many significant figures are in the following? 3.0, 3.400. Yes, I heard you. You got it right. You got a correct answer, and that is for significant figures. And 3004. So take note, all the two zeros are sandwich, meaning to say they're in the middle of the non-zero digits. They're in the middle of the significant digits. So that's why you have to consider them as significant. So therefore, there are four significant figures in this number. Ang 300 point something else. So take note, if the number is 9 decimal and large, then if the number is 1 or greater than 1, kanang mga zeros din ha, either to the left or to the right are significant. So there are three significant figures. You are correct. Last, 0.003, 3040, mga 0 after sa decimal point na kay duha ka 0, 0, 0 ay 3. Kanang 3 significant. Kanang 0 between 3 and 4 is significant because they are sandwiched zero. And then kanang 4 is zero, kanang zero after sa 4 to the right is significant. Significant na siya always. That's according to the last rule. So therefore, there are four significant figures in this slide. Answer. That's it. That's how we're trying to apply the rules of significant figures. How many significant figures are each in the following measurements? Say, for example, you have 24 ml, you have 3,001 gram, and 0.0320 cubic meter. So how many significant figures are there? Yes, you got it right. You are correct. And also with this one. And also with this one. Yes, 2, yes, 4, yes, 3, yes, 2, yes, 2. That significance because you are really master in the certain topic. And when it comes to addition and subtraction, take note with the addition and subtractions. What are the four operations of basic mathematics? Addition, subtraction, multiplication, and division. So the rule for addition and subtractions is similar. The rule for multiplication and division is also similar. Let's have first the addition and subtraction. So the addition and subtraction cannot have more digits to the right of the decimal point than any of the decimal numbers. Say, for example, 89.332 plus 1.1. So, how many significant figures sa first sa 89.332? Diba? There are 5 plus 1.1, there are 2 significant. Ang iyang answer is 90.432. So, total sa significance sa iyang answer is there are 5 significant. But what is the least significant after sa decimal? Ang 89.332 after sa decimal, ana na ay tulo ka significant. Ang 1.1, so after sa decimal sa 1.1 is 1 significant. So meaning to say, imong answer is 90.432. Imong sundon, you have to follow that your answer should only one significant digit after sa decimal. In that answer, 90.432, you should have one, di ba, how many significant after sa decimal sa answer? Tulo ka ng 4, 3, and 2, tulo ka significant. So since you should have to follow the rule which is 1, so you have to drop the 2 and 3 so that you have an answer of 90.4. So in that case, 1 significant and rounded off to 90.4. Yung 90.4 lang man because sa given nga pinaka least is 1 after sa decimal. Second, 3.70 and minus 2.9133. Ang after sa decimal point sa 3 is 2 ka significant, ang 7 ang 0. Sa second, after sa decimal point sa 2, di ba, 9, 1, 3, 3, there are 4 significant. So meaning to si pinaka-list, si 4 or si 2. So meaning to si imong answer na kay 2 ka significant after sa decimal point. So you have to drop the other significant digit. So kana siya after sa decimal, 2 significant. Kana siya imong answer should be 2 significant after sa decimal, and that is the very basic for algebraic operation. Okay, and for the multiplication and division, the number of significant figures in the result is a set by the original matter and has the smallest number of significant figures. So meaning to say that say for example 4.51, pila na siya ka significant all in all? So there are 3 significant times 3.6666. So how many significants total, ha? So there are 5 significant. Sa multiplication and division, you have to count ang overall significant. Ang pinaka-least ng overall, imong answer mo po na ang significant digit niya. Okay, for example, pila na siya ka-significant? Tulo sa tanan, ha? Multiplication na siya, division. Kanina, pila na siya ka-significant? Kinsa may list, si tulo or si kanang sa pikas nga 1. So meaning kasi imong answer should have 3 significant digit because that's the least and smallest in the operation of multiplication and division. So instead na 16.536366, i-drop nimo na sila, dapat ang total ana is tulo ka significant. So 16.5 is a significant, 3 significant digits. So that's your correct answer. And for the division, 6.8, pila ka significant? Duha. Ang 112.04, pila ka significant? 5. Kisay least, smallest, si 6, si duha or si 5. So meaning, the smallest significant in the operation is si 2. So therefore, your answer should have a 2 significant digits all in all. So initially, your answer is 0.0606926. So how much should be your significant digits in the answer? In the correct, it should have 2. So you drop the to 6 to 9, 6, and instead na 0, you put 1 to consider it as have two significant digits. So two digits, you should have two significant. So 0.061. So there are two significant digits overall. Ang exact numbers, yes, the average. For example, this is another example. Please take a view with this one. And 6.6 is because 3 is an exact number. Okay, so let's move on to rounding off numbers. Ang rounding of numbers is a fundamental principle in the mathematics, particularly when dealing with significant digits. So adhering to the rules of rounding ensures that the precisions and accuracy of measurements are attained. So the process of rounding significant digits involves specific guidelines to determine the final value with the appropriate level of precision. So by following these rules, the rounding of significant digits becomes crucial and step in ensuring the accuracy of numerical calculation and measurements. Well, there are rules of rounding of number. First, identify the digit to be rounded. Second, look at the next digit to the right for rounding. Eh, if you're trying to round off the number, if the number digit is 5 or greater than 5, round the identified digit up. So meaning because if the number to be dropped is 5 or greater than 5, so the next number to follow that 5, you have to add on 1 to increase round up. Number 4, if the next digit is less than 5, so the digit is unchanged. So meaning to say you do not have, do not change anything at all if you remove the number of less than 5. Okay. And number 6, keep the same number of decimal places in the round results in the original number unless specified otherwise. Yes, that is correct. So practice, complete the table, round the following numbers to one decimal place. So meaning to say, after sa decimal place, dapat, decimal point, dapat na, you have only one significant digit. Okay, so say for example 6.78, so round up to 6.8, so only one significant after sa that. 4.93, so you have 4.9 supposed to be. And then the second column, decimal places, round the following numbers to two decimal places. So meaning after sa decimal places, your number sa significant digits should be 2. For example, 3.7854. So ang pinaka-significant digit after sa decimal 4. So dapat i-round into two decimal places. So it should have 3.79. And to the nearest whole number. So 23.6798 nearest whole number. So meaning to say 23, i-drop mo mong 6, so mag-add na kag 1 sa 3. So that's why 24,000. It should have 24 rather. Well, you have to look number 1 until all of that exercises because the answer is here. And before you're trying to attempt to answer this number, please assess, evaluate yourself if you do understand so that you will be assessed and something offer and a help to offer. Yes, that's it. So next is the exponential notation, or scientists are lazy. They decide that by using power of 10, they can create short versions of long number. What is the really designation or design in the scientific notation? Why we use this scientific notation again? Because in this field of science, scientists especially, they're dealing with a very large number and very small number, smallest to the most smallest. So therefore, if you deal with those numbers to avoid error, you have to use scientific notation. Okay, so how to write the scientific notation? Rules for the scientific notation. To be in a proper scientific notation, the number must be written with the number between 1 and 10. That's your base. And of course, especially is multiplied by the power of 10. So 23 times 10 raised to the power of 5 is not a proper notation. Pilaman, because 23 is not within the number from 1 to 10. It should have changed. You should have changed the 23 to make it as in the middle of 1 to 10 or less than 10. So 2.3. And that is a very safe answer. So, say for example, in exponential notation, and we have to write that one. As in the application, kinanglan, dili mo lapas sa 10 ang imuang base number. So pila ka zero, 6. So 1, 2, 3, 1, 2, 3, 4, 5, 6 until sa 7, 7, 8. So 1, you will not write it as 137 because in the rule, it should have in the range of 1 to 10. So it should have 1.37 times 10 raised to the power of how many decimal places that you have been moving. And that is how to get the exponential scientific notation. Using the scientific notation, we write the following: 3.347,000. It should be 3.47,000 times 10, 3.47 times 10 raised to the power of 5. And 61,400 is 6.14 raised to the power of 4. Okay, that's what we're trying to remember. And always choose a number that is in the mid between 1 to 10. Exponential notation, how to convert this one. Okay, I will give you the activity with this one. And of course, convert that into decimal places. And try this also, 4,000 scientific notation. How will you write that into scientific notation? It should have 4.0 times 10 raised to the power of 1, 2, 3. And 2.48 and etc. Mga siya, 200, 2040 and 6,123,000 and of course 3.06. So that's how we are trying to write the scientific notation. In the United States, 15,000 households use private wheel for their water supply. Write this number in scientific notation. Of course, 1.5 times 10 raised to the power of 1, 2, 3, 4, 5, 6, 7, etc. Depending on, yes, that's 7. More example, from 1 to 5, the decimal places is less than 1. No? You write that into scientific notation, just simply make a base. And 1.238 is just an opposite of number 1, so elucidate that value. Okay. And last, dimensional analysis. What is dimensional analysis? That's a converting units from one unit to another. Yes, because when the units they are using is not the desired unit for the problem to be asked, then you have to use conversion factors or converting that certain units to another units, leading to the correct answer or the correct units and answer as well. And dimensional analysis, the skills of converting one unit to another is called dimensional analysis. It's involved three factors. Letter A, the unit in a given problem. The unit answer should be in just like that. So a fraction that is always equal to 1. For example, 1 kilogram equals 1,000 grams. So that is their value. In every 1 kilogram, that's equivalent to 1,000 grams. Now, you're trying to get the gram or kilogram in the future. Just look and use that conversion factor. So how the conversion factor to metric factors? Just convert from kilogram to gram. Use the desired unit leading to correct answer. Okay, that's it. Since ang 1 kilogram is equivalent to 1,000 grams, so whoever should be in the denominator and numerator, well, for the purpose of so that you will cancel out from numerator to denominator. Okay, so just inverse your method or conversion if depending on the type of units that you are trying to compute. And just like that, yes, 2.5 kilogram because you are asked to calculate the what do you call it, convert that 1 kilogram or what to 1,000 gram. Okay, so dimensional is there are 6 methods in dimensional analysis. We define given problem, set up the problem, and of course find the conversion factor, multiply and divide, record the answers, and check your work. So these are the steps in getting the dimensional analysis. Okay. So read the given problem, determine the units you are converting to, what units your answer should be. Of course, depending on what is being asked, that's your answer. Okay? This is for how to do conversion or metrics unit. And of course, that's simple basic operation, no? In algebra application, well, we have to apply that here, even trigo and calculus in the higher topic. Okay? The answer is 1,200 kilometers. Example again, if given Gavin is running with a football of 30 feet per second, how fast is the meter per second? It is simply operate that one. Numerator 30 feet per second, and the conversion factor to meter per seconds depend on you. Last example, if Caitlin is in a Mercedes traveling 15 mile per hour, how fast is that in feet per second? Well, you have to use the conversion factor leading to that desired unit in terms of feet and seconds. Okay, well, that's it. That's all about my YouTube video and discussion in the week number 2. Again, for the week number 2, the title for that is measurement. Then after this one, you will be given an activity sheets, and of course, you have to consider that you could have the peer coaching during the activity. When it comes to the quizzes and the term exam, no one should ever to ask question to anybody else to avoid any problem, right? So again, this is week number 1. I will give you quiz and I will give you an activity, and then we have to move on for the next week about week number 3. I think that's atom, molecules, and ions for the benefits of other. For the sake of other, just try to read in advance about it. But for now, please, thank you for patronizing my channel. Thank you for watching, and of course, it's my pleasure to visit my channel. Don't forget to subscribe the notification bell, or to click the notification bell and subscribe the button. Okay, and then always keep watching in my YouTube channel. This is me again, Rafael Padla Inson, and thank you for watching. Okay, so bye bye.